Okay. Good afternoon, all. Myself, Dr. Professor Subodh Panda. In today's, I welcome you all on today's video lecture class. So here you will see a satellite communication, the fundamental and basic of this satellite communication system. Basically, this is a subject belonging to 8th semester, 4th year students under GNTO. So, before going in details about the subject, the first one is why we want to read this subject. So, let's see why we need this subject. As earlier semester, we know in more details about how voice or data can be communicated, and because of that, we have read an analog communication system, digital communication system. At the end of both the subject, we are acquainted with how voice and data can be represented successfully from point to point. But simultaneously, when we go through the wireless communication system, we learn details about how data or voice can be communicated in free space with electromagnetic waves. But even though everything is possible and feasible to us, in certain moment we are unable to represent our data and voice in a long distance which is far away from us, or sometime in point-to-point system. So, even though technology is available to us earlier to this, we are capable of representing information to different resource, different point. But if the distance is much more beyond the limit, if the amount of data is much more, we are unable to represent with this earlier system. So we need a system which can support us for representing the information in a long distance with multi-point system. And that is the role of satellite communication in present scenario. So, why we need the satellite communication? That we basically know. Now just see what basically fundamentally is satellite communication is. So my dear friend, satellite is nothing but a system which with respect to microwave principle is available on a imaginary path called as orbit with a certain distance or sometimes far away from the earth. So with the help of this satellite system, which may be in a fixed position or may be moving around the earth, we can communicate our information from source to destination without directly to point. We can move information from the source to the satellite and from the satellite to the destination. So now we'll see fundamentally what a satellite communication or the satellite system can be represented in a simplest way through this block diagram representation, or from this simplest block diagram of satellite communication, basically we are now capable of understanding what a satellite system is. Let us now, we want to communicate data or voice. So at present data and voice with us, and that we want to communicate to a destination. We can send from this to this, but as I told, if it is a long distance, we need an earth is around, we need a antenna, we need number of antenna in multi-point, and that may not be feasible in all respect. And we know that microwave cannot be bent at any cost, so it has to move in a straight line. Hence, if we cannot use from this point to this point in the earlier process, so we need a satellite in between. This is my satellite system. Now, this available information can be represented into a suitable form which can be transmitted successfully. That is our system for converting. Okay. Now, data has to be sent successfully in the form of representation, which can now be transmitted through the antenna. Most probably it is our part of the antenna. So my dear friend, the total satellite communication system consists of three parts. One part is station at the earth called as a transmission center. At the top, the space center, which is represented by our satellite, and once again at the earth, the receiving point. So now signal is capable of transmitting in this way, where this path is called uplink. In the same way, transmitted data from the satellite to the receiver. Once again, there is an antenna which has to receive, and this is our downlink. Now, in between, what do you observe? This system basically consists of three different units mostly, and it is called a transconductance. So, my dear friend, transconductance is a main unit belonging to satellite system. It has a role of receiving, amplifying, making the signal into multi-frequency, then transmitting. A togetherness of all operation. This receives the information coming from the source, it amplifies it, then it converts into multi-frequency form because we have to receive at different resource at the receiving terminal. Then it is now ready to transmit with help of this system. This this block diagram represents us a fundamental behavior about the satellite system. Now we see what is the basic principle behind this satellite communication. The moving around of the satellite through the orbit through the earth is not a big thing. And this science already we know. The force of gravitational force, whenever equal to centrifugal force, then a body can move around with respect to a center. The same principle which we learned too early during our 10th and 12th, that can be utilized in the process of designing an orbit around the earth through which our satellite has to move. But before that, basically we know our satellite system consists of two different parts. One is when satellite is sometimes fixed, sometimes our satellite is movable. In earlier stage, when we were at the beginning of satellite system designing, mostly the satellites are fixed. It is not in the position to move around the earth through a given orbit. Because it is fixed, it is only allocated to some given network. And this structure has some laggingness. It cannot support the multi-point system. Hence, this is outdated. And we need a system of satellite which can move around the earth through a given orbit. Hence, this system is represented in the form of passive satellite system. Then another one is active satellite system. In both the cases, so in case of movement, when the satellite is about to move through the earth with the orbit, the basic science represented as a centrifugal force equal to gravitational force equal to centrifugal force, and this is our can be represented F in and this is F out. That is, this is the force given to the system and this is the output of the force. When both are balanced, then only the system can move around togetherly. And the same principle can be represented here mathematically also. The total gravitational force available can be represented as mass of the earth. Gravitational force. Here mass, gravitational force available. So gravity, center of gravity, and this represents our radius of the earth, and this represents distance between center of the earth and satellite position. Whenever the same way, centrifugal force can be represented as mass of the earth into r into this omega represent angular frequency. Well, because all these things we can calculate, we can represent this and we can represent this. If these two are equal, then we assume that our satellite can move around the orbit which is pre-designed. When after design the orbit with the given calculation, our satellite can be placed in this location and start revolving with getting different information, and it can be represented in the multi-form as I told earlier. This location. So what we observe? This satellite now capable of representing information in total one third of the total Earth. If you want to communicate all the information throughout the Earth, that is, example is whenever we need information in the time of Olympic Games. So all of the information has to be spread. We need minimum 3 satellites in different locations so that it will cover all the information for the all over world people. Now we'll see orbit. Because in the process of designing satellite system, the designing orbit and its location is highly essential. Hence, basing upon that, we can achieve the application of each and every satellite. Basically, at present, we have 3 different types of orbital position. One is geotype, another is polar type, and the third one is inclined. In case of geotype, it is purely horizontal and it is 3,600 kilometers away from the Earth. In this case, both satellite and the Earth has to move simultaneously, synchronously in the same direction, and rotation of both are almost equivalent to each other. Hence, the rotation of the satellite to complete this path, it will take around 24 hours. This type of representation of orbit and the system of satellite can be useful mostly in broadcast system. But sometimes, in case of other representing, we are not using this, but in this case, this is our orbit, which is called polar system. In case of polar system, it is 90 degree and just 1000 kilometers from the Earth. Whenever the orbit position is not horizontal and 90 degree to the Earth, and position is just away of 1000 kilometers from the Earth, this type of orbital position is called as polar orbit. And mostly application of this system is for weather broadcasting. And sometimes, whenever we want to use the satellite system for mobile communication or communication purpose, instead of using this, we simply need an orbit which is just a 66 degree to the Earth. So, in case of geo, it is horizontal, 3600 away, used for broadcasting. This is 90 degree, 1000 kilometers away, and used for weather reporting, example. And this is inclined type, which is 63 degree to the Earth and useful for mostly mobile communication system. Now we see each and every system has some advantage and disadvantage. So before discussing advantage and disadvantage or limitation or scope of satellite communication, we will see, we want to know something about a basic important point, that is whether the satellite is visible to us from the ground station or not, and what should be the exact position of the satellite so that we can communicate our information from the source comfortably. So, look angle. These 2 points are most important in the process of designing a system. Look angle represent when the visible to us from the earth station. And projectile position represent how successfully our satellite can reflect the information received from the transmitter and to the receiving end, because it has to represent in the multi different frequency to the multi point, and the corresponding angle must be zero with respect to earth. So this representation is called projectile position of satellite with respect to orbit, and this represent the angle of receiving station with respect to the satellite. So these two is most important, because whether the satellite is visible to the earth, that means whether there is transmitting point, the signal can be represented at the satellite successfully without any rupturing or without any interfacing much more or delay. In the same way, this will help us to represent our information at the receiver and successfully without any maximum delay. Now we'll see what is the advantage of satellite communication and what is the disadvantage, some of the disadvantages. The first one, why we run behind the satellite communication, as we discussed earlier, this will represent a multi-point application. So when we want the same receiver at the same time synchronously, at that time no other networking system or no other communication system can support other than this. So worldwise we need satellite communication for a single information at the same time. The delay time of this is very less as compared to the wireless system or even though in fiber optical system. The total cost of the system as compared to others is little less. Only the cost of this is how to launch this program. Once it is successfully complete, then its maintenance cost and lifetime is very less as compared to the other communication system available. Even though it has some advantage, it has some limitation and disadvantages also. That is because information is moving from satellite to the earth with multi-frequency. The most drawback is security system. So we have to think about the security so that nobody can use or reuse the information coming to the earth station before received. The second point is the cost of total system. Even though if the launching is successful, then everything is comfortable. But the process of segment 1, the earth station, 1 and 2, receiver and transmitter, and satellite. When we compare the 3, it is little bit higher as compared to the other system. But in case of this multiple system is not available, security system we have to allow that, and we have to think about the cost with respect to not only launching, with respect to 3 stations here. So this is for today's representation with respect to satellite communication. So here we discuss about what the satellite is, why it is the subject, what basically it is, how it can be represented fundamentally with respect to the block diagram. Then the basic things in orbit we discuss and its application. Next, the most important point, how it can be represented by the resource with respect to look angle and how it can be available to the receiver with respect to point angle. Then its limitation and discuss. Thank you all.